Hey everyone, welcome back to this week's live stream. Today we're going to be talking about pre-wiring the 600 amp hour off-grid power system that I have behind me. And throughout this stream, feel free to ask any questions. What we're going to go through is very specific details related to the components that are in here. And more specifically, we're going to talk about the cabling and wiring from the 6-gauge wire that we're using up to the 4-aught wire. If you have any questions, if you're well versed in electrical components, then this video will be kind of fun because you can kind of see maybe how I lay this out. If you're maybe building your own system or already have built your system, but if you're new to the 12-volt off-grid power system, this might be a nice way to see what it could be, or what, if you're putting this system together, kind of where to start from. So to kick off on the agenda that we got today, let's go through our list. So we're pre-wiring the 600 amp off-grid power system behind me, and we've got a lot of stuff. So we have all the supplies here on the left, and then we got the tools that I'm going to be using on the right. So the supplies on the left-hand side, this is going to be everything from the cables that we're going to use. We'll talk about the difference between 4-aught, like I just said, 6-gauge, the copper lug and ring terminals. We'll go through, talk about ferrules for the solar disconnect breaker, as well as the breaker itself. A couple components as far as how to put together the 80-20, so really how everything's put together, held together. Different parts like the 80 series or the 15 series 80-20, the 15 series 80-20 90-degree brackets. There's really only two components that hold this whole system together. These two pieces of 15 series, and then the washers and button head cap screws. Further down, like I just said, solar disconnect box. We'll talk about the dual pole breakers, why those are important. Then we'll talk about Blue Sea system components. We'll be talking about the battery disconnect specifically, the Victron Links distributor. I actually need to put in the Victron Links shunt because we're going to be talking about it as well. So let me edit this. So distributor and the smart shunt. And once again, if you guys are not familiar with any of these components, that's what we're here for. This is kind of like a build and learn live stream today. We'll go through, again, the Victron Links distributor and the smart shunt, and then the Renogy components. So we have, behind me, we've got the two 50 amp DC to DC MPPT charge controllers. We've got the new Renogy Rego 3000 watt pure sine wave inverter charger. And then we have 6 of the Renogy Smart Lithium batteries. And most importantly, these are the ones that actually work with the Renogy 1 unit that we'll be putting in later. Then over on the right-hand side, we'll finish it up with talking about the tools kind of throughout the stream. Hydraulic cable lug, the crimping tool. We have wire cutters, the Crimpro crimper for the wire ferrules. So those ferrules, we'll talk about them if you don't know what they are. They're essentially the wire ends that need to go into the solar disconnect breaker. Klein tools, everybody likes Klein tools. We have a wire stripper and cutter. Then finally, we've got the Jonard round cable stripper. That is a very important item we'll talk about. So I use this a ton when I'm putting these systems together. And last but not least, we have a pair of standard crimping pliers. I actually have a Cobalt crimping plier, but this Gardner bender is the only one that I've been able to find on Amazon that is most closely related to it. And speaking of Amazon, the reason I put these tools here is because if you guys haven't watched the past streams or the channel, or you're new to Van Builder HQ, I put together a DIY Van Build cheat sheet. And so essentially what this is, it's a curated list of products from Amazon that I've used over the last 3 years So the components behind me, the tools behind me, the stuff that I purchased through Amazon, it's on this list. So if you want to find a quick way to help save time and money, saving time by having all the tools in one place to choose from this list, such as what we're working on today over here. All of these tools will be on this list. There'll be some new ones that we'll add to it. This list also includes the hardware. So any type of the hardware or fasteners that I'm using to actually secure all these 80/20 pieces together, they're also available on this list. The best part about the DIY van build cheat sheet is it's completely free. And when you put your name and email address, it's going to come directly to your inbox, and you'll be able to take it out, go through and find a lot of the items that you need to do your DIY van build much easier. So again, it's what I've personally bought through Amazon over the past 3 years. I've vetted all these products. They're probably right behind me in the shop if I haven't already used it on a customer van. And I think it's really helpful for you guys. So I put it together. It's a really easy download. Just put your name and email address. Again, completely free. Comes straight to your inbox. And the Amazon links is definitely an excellent way to help support the channel when you click on these links. So check it out, DIY Van Build Cheat Sheet. And here are those tools. We got the tools right down here. So let's see where we're going to kick off this stream. If you haven't been keeping up with the live streams or videos on the channel, we're building a adventure van. It's a Ford Transit, all-wheel drive, high roof. It's a 148-inch wheelbase. It has the Adventure Wagon interior kit and then a lot of components from Flatline Van Co. To run this whole system, we're going with this type of off-grid power system. And this is the battery sizing here is more specifically geared towards the Dometic RTX 2000 AC unit, the rooftop AC that's actually behind here. So we covered that in a past live stream, talking about questions that might be raised when you purchase the unit. And I wanted to, if you guys haven't watched that video, watch that video. If you have any questions on what you would like to learn in a future live stream, or actually when I go to install it, that's what I'm really looking for. So I did that kind of pre-install video to go over the specs, what components that I'm purchasing with it. It also goes over what's not included in the system, so that if you are deciding to purchase that unit, you're ready to check the whole list off and go ahead and purchase it before you install. But we're installing that unit, and upon my research, to really be able to enjoy the unit, you're going to want to have somewhat of a substantial battery bank. It's something that's sized enough to where you can get 2 or 3 nights of use out of it, and that really depends on how big your battery bank is. So for our off-grid system that we're using in this van, anything from 200 to 400 amp hours is probably pretty good if you don't have an AC unit. And then you have pretty good solar, so say around like 400 watts on the roof, as well as alternator charging. However, when you have a rooftop AC unit, the benefit of using a 12-volt rooftop AC unit like the Dometic RTX is that it's very efficient. But although it is efficient, it can't be used forever. So if you want to extend the time that you're nice and comfortable at nighttime in the van, and you're off-grid, so that means you're not plugged into shore power, it's in the afternoon, you're not getting solar, you're really relying on your batteries. And we talked about in a previous stream how you want to size the system not only to what is going to have the main consumption of the system or what you anticipate being the main consumption, but also kind of splitting it into 2 systems. So it's all wired as one, but kind of in your head you have it segmented into 2. So maybe 3 100 amp hour batteries to take care of your microwave, hot water heater, the inverter, charging your laptop, stuff like that, the lighting in the van, maybe a parking heater, those type of applications. And then having, in this case, 3 other batteries that are reserved for strictly just the air conditioning system. And by doing that, you kind of throttle your use so that in the daytime, whatever solar you do get, it can replenish what the AC unit used, and then your other batteries are kind of there to keep you for the weekend, operating all the other components. In a perfect world, you might be camping for maybe 2 or 3 days in one spot, and then when you go to drive, you're going to have that additional alternator charging with the solar, and that's really going to be the main way to top off your batteries. So that's kind of the reason why I have 600 amp hours in this system. The other reason, and this kind of is becoming a theme in the shop here, when we did Thomas's van, so that's Marine 1, we were very limited on space because of the checklist we had to go through as far as how he was going to use the van. So the electric wheelchair that was going to go in the van, such as the Paragolfer, being able to move around in the van, that took a lot of the width and length of the interior. It caused it to be fixed and open. So along the sides of the van, we were very limited in our space for everything. For the hot water heater, we were limited for the batteries specifically. So in his van, you'll notice in this arrangement, we had the batteries going width-wise. In his van, we were limited on this distance. We had to be as wide as possible. So the batteries had to be turned long ways, and we only were able to fit 4 batteries in his van. So that was his max system. Now what we did to offset that was we have 550 watts of solar up on the roof. And so that's going to kind of make up for that battery capacity by being able to charge the batteries faster, or just a little bit faster. In this system, the profile that you're seeing, this is from, so inside, this is on the driver's side of the van, and on the side right here, we have one of our kitchen galleys. So we have 2 kitchen galleys. We have the main kitchen galley on the passenger side of the van, and that's going to house the sink, gray water, drawers and more storage, as well as the induction stove. And then this is the driver's side, and this is going to house 24 by 24 kitchen galley where the Isotherm Cruise 130 fridge is going to be installed. So once it gets installed there, that'll be the back side of it. Let me make sure this is connected. So you can imagine we have a driver's seat, we've got the flip and fold, and then right here along this side, let me try to get you a visual here. Yeah, this thing is so heavy I can't even move it now. I was able to move it earlier when I had the batteries out, but this thing is very heavy. That's the one thing I did not do before the live stream. I was going to weigh or do a little chart to show you the weight of the system components. All right, so if we have this board right here, imagine this is the galley, the kitchen galley, the 24 by 24 inch behind the flip and fold seat. So driver's seat, flip and fold, isotherm fridge right here. So directly from the isotherm fridge all the way back here is as much room as we have. So that's the maximum room in a Ford Transit if you have this set up. So the only space we have to work with is 65 inches. So that was our footprint. We have the 6 batteries here. And now I'm kind of going through the components. And don't worry, if you guys, in a minute, we'll go back to this slide. So if you want to do like a screenshot of this, obviously this is a live stream, so you can go back and check it out at any time. But we're going to start going through a couple of these. So we have our Renogy smart lithium iron phosphate batteries. They're called smart batteries because they actually have a little network connection on the top of the battery. So I'll just slide one of these out. And you can see we have smart lithium iron phosphate. And up on top, we have our little network port at the top of this. And so what you can do is, or what we will do, is we're going to, make sure my microphone, we'll link up all these batteries together, and then they'll communicate with a hub. And so that is the, let me see if I can grab it really quick. Because I know some of you guys have not seen the past live streams, so I'll try to get that together. All right, so we got the Renogy 1. Let me see if I can find the hub box over here. All right, we'll have to come back to the hub box. Well, I'll look on the computer. But we have our Renogy 1 controller. And let's see here. Yeah, I'll explain that. I'll explain that as well too, Daniel. That's a good point. So the Renogy 1, I'm going to put the box over here so that later here in the stream we'll circle back and we'll talk about this box. But essentially, all these batteries are going to network into a hub. Both of our DC to DC chargers down here will plug into that hub. The Renogy Rego has a built-in Bluetooth connection, and so that will everything communicates to Renogy 1 via Bluetooth. So the reason you need the hub is for these batteries that don't have integrated Bluetooth. You can get the ones with it. So these were purchased last year. The new ones this year, they have built-in Bluetooth. So we're going to network these to the hub instead of the integrated Bluetooth, which it doesn't have. Now, 3 of these batteries are self-heating batteries. So every other battery is going to be a self-heating battery so that it can operate in temperatures below freezing. But it'll keep the battery at a temperature above freezing is what I meant to say when it gets that cold. So you will still have power. So coming back here, this is where we had to stop because we ran out of room. And Daniel just mentioned about bed height. So from the floor to the top of this box is 21.5 inches. So if you did want this to be the top of your bed, you would have a ton of headroom in the van. Right now, the reason that this is at a certain height is the bump out to the Transit. I wanted to have a clean transition to the curve. So the curve, or the factory bump out that's already in the Transit, this curve meets with this plane right here. So it just kind of curves up. So it's going to be an excellent transition. The bed system that's in the van right now is from Flatline Vanco. It's the Adventure Wagon compatible bed system. So it is movable. So if you wanted to take out the kitchen galleys which there you can unbolt them in this van, and you wanted to lower your bed even more, you could do that all the way down to this height. So once again, technically your bed could be all the way as low as 22 inches. So that's our length. That was our height. The width of this is the width of a battery. So that's kind of what we wanted to do. So that's 11 1/4. These batteries are 11 1/4. Now you may ask, why did you make it exactly the width of the batteries? Well, I know this front face is going to be clean and flush. The back side, however, curves. So you've got the natural curvature of the van, and the natural curvature will have a gap. And so that allows the batteries to have some space on the back, about 1/4 inch. So there is we won't have wiggle room because this will be strapped down, but we want this wiggle room. We want a little bit for battery expansion. Now you don't want your batteries to expand, but the hot and cold, like the plastic cases and stuff like that, you want a little bit of wiggle room, like maybe like 1/8 of an inch or something like that. So that's our width of this system. So we have with the batteries, we come on back and you guys see our links distributor. So once again, if you're watching, we're going to talk about our components really quick, and then I'm actually going to take this off. I'll show you the internals of the links distributor. We'll talk about these two components, the inverter, and then we'll start going into why I wired it the way I did, why I used the certain gauge that I did, and then how this is all integrating into the distributor itself. So you'll learn how power is flowing into the system, both from the engine, from the solar panels, through the components, into the distributor, and then back into the batteries. What's nice is, since we have it on the bench here, I can kind of show you the insides of it before we get too far. And if we have time later, and you guys are interested, I'll just keep streaming, and I'll actually teach you guys how to size up and make the battery terminal lugs up here. So the wires that are actually connecting the batteries. So we're using 4/0 cable for that. So if you're interested in that, let me know. And we'll kind of keep the stream going like that. I do want this to be a Q&A kind of learning live stream. So definitely, if you guys have any questions, put that in the chat. That is what this live stream is for tonight. Batteries, links distributor. The links distributor, we're going to take the cover off. If I can get my screwdriver. If you guys are new to 12-volt electronics or RV power, don't get overwhelmed when I open this up. It's going to look pretty wild, but it's okay. It looks really complicated, but I promise you, anybody can do this, as long as you kind of follow step by step, go nice and easy. First off, why did I get a links distributor? It's a very simple way to attach the batteries, the shunt, the inverter, and your charge controllers, since they typically have high current load, in one place. High current devices, you're going to have, chunkier fuses, and this uses mega fuses. So not only is it using the same fuse, but high current loads can go through here very easy. So this is our links distributor. This is this is kind of the intersection of where all the power is flowing through the system. So we have power flowing in here from the batteries. We have power flowing in here from our charging system. So this is kind of where everything happens, and then it's also where everything is protected. So we're going to come back to this. We will circle back. So from here, we come over to, we'll talk about, so we're going to do 1, 2, 3, and 4. We'll talk about, that's probably a good way to do this. The first section, or the first circuit here, this is reserved for our rooftop air conditioning system. So our rooftop air conditioning system is the Dometic RTX 2000. The manufacturer, Dometic, recommends an 80 amp fuse to protect this circuit. The wire coming from the Dometic RTX 2000 is a 4-gauge wire. So what we'll have, this is coming in a future video, so just come on back later. we'll have the install video. I'm waiting for, so probably in 2 weeks is when I'm going to have scheduled to actually cut the hole in the roof and start installing it. Tomorrow I will be, well, in 2 days I'll be receiving the DIY van roof template kit. So we'll get that. Once I get that, then I can actually start mapping it out before I cut a hole in the roof. Now, 2 wires here. So I researched this because if you guys, this has to do with the wiring. So the last video that you guys saw on the live stream, we talked about the Dometic RTX and what was not included when you purchase the unit. So you know that I purchased the unit and I had to buy not only the AC unit, obviously, but I had to buy 2 other packages with it. One was the installation kit, or installation hardware kit, and the second one was the wiring kit. Now in the installation hardware kit, this cable came with it. Now check it out. There you have this cable, and then you have this cable. So this is with the installation hardware kit. This cable you had to buy separately. And so my question was, why do we have 2 power cables from 2 different kits? So maybe obvious to some, but I'm sure some of you guys don't know. The smaller wire, this is the power wire, and it's included in the installation kit with the fittings, but this is for a 24 volt power system. So if you didn't have a 12 volt power system, once again, this is a 12 volt power system. But if you had a 24 volt system, the hardware kit comes with a 24 volt power cable, which is about half the size of the 12 volt. So when you have higher voltage, you can have lower current. That's why the wire's thinner. But we needed to buy the electrical install kit and had this chunky 4-gauge. So this chunky 4-gauge is why we need an 80 amp fuse to protect the 4-gauge wire. So eventually what we'll do is we'll unwrap this, and this big chunky wire is going to go through up the pillar of the van, up to the roof, plug into the AC unit, and then the bottom end is going to come down, and we have these lugs. We'll need 2 of these. So we're going to need 2 4-gauge 5/16 ring terminals. That's also what they're called. And what that'll do is one will connect to the negative down here. The other one will connect to the positive up here. And then they'll be heat shrinked, but these 2 connections will connect to this wire. And then that way, we're providing power to our AC unit, and then we're also protecting our circuit as well. So this fuse is protecting the power from the battery to the unit itself. So this fuse is protecting the wire that is in between the AC unit and this bus bar, which would be this positive wire. That's what this fuse is for. So the first one is going to go to our AC load. Next, we'll move over to our biggest current circuit, which is protected by a 300 amp fuse, the 4-aught cable, and that goes to our 3000 watt pure sine wave inverter charger. Now it's an inverter because it's inverting the 12 volts to 110 or 120, for household power. We'll be wiring that to, let me get this for you. Got all kinds of goodies on today's live stream. So this is our 120 volt circuit breaker panel from Blue Sea Systems. This thing is great. It's very small, compact, and all the power that's coming out of here, down here at the bottom, will be going into this breaker panel for the 120 volt circuit. So that's where these cables are going into the inverter. They're very big because this is going to take up, it's going to take a lot of current to create that 3000 watts. But the nice thing is the 3000 watts, and this was a question in a previous live stream, why do you need to go so high on wattage? Well, think about it. If you have a 1200 watt induction stove, and let's just say you had a 1200 watt microwave or just a 1000 watt microwave, we're at 2200 watts using both of those devices at the same time. Now add in, say you wanted to have hot water while you're cooking, maybe you're doing dishes or something like that. You got to think about what demand is your 120 volt AC load going to be, so that the livability of your van. So what the livability means to me is how many devices can I use at the same time like I would in a normal house, heat something up in the microwave, wash my hands with hot water, be cooking dinner on the stove. What devices would I normally use at home that I want to replicate in the van, so it just, the livability, feeling like, I have a nice kitchen in the van, to emulate that. And so that's why you go from like a 2000 watt inverter up to a 3000 watt inverter. So this is what is supplying power to it. Now, the next circuit we have is our two, they're protected by a 60 amp fuse, but these are our 50 amp Renogy DC to DC chargers. Technically, you could do 65 amps up here. They don't make a 65 amp mega fuse that I know of, so we just went down to 60. Through testing of a system, if you find out this trips, maybe it has like a nuisance trip, it's possible you could go up to 70 amps, but really the maximum capacity of this 6-gauge wire is 50 amps. So 60 amp protection should be good. These DC to DC chargers, even though they are rated at 50 amps, usually what I see is about like 47 amps when I've been using this personally with my own van. So we have two here, and what these fuses are protecting are the cable is the power cable between this distributor and the DC to DC charging units. So on this side of it, we have power being used coming through the distributor. And then on this side, these two, we have power actually coming in back into the power system. And so it's kind of confusing because you think, how does stuff go in and out at the same time? That's just kind of the way that electricity works. It's really interesting, but simple at the same time. But essentially, power will be fed into here, and it'll be used over here, and vice versa. Not only is the power going to be coming in from the alternator, or the batteries up on the front of the car, but it's also going to be coming in from the solar panels. So these 2 points They will not be going into this. We will be putting the power through a different method into these. And that will be coming through our solar disconnect over here on the left-hand side. So the solar disconnect box, I'm going to pull this up. This is a HT-5. So I didn't add that to the list. So if we go to Amazon, let's see here. So if we go to Google and type in HT-5 electrical box. Hey, Jamie. The HT-5 electrical box. Go to Amazon. So probably 2 years ago, I found out about this box from Explorers.life. You guys have probably seen him on YouTube. But this box is really nice because it's an IP65 rated box. It's going to be inside your van, so don't really worry that much about water resistance, because typically you're going to want to install this to where it's not going to get rained on. However, in my scenario, mine is at the back of the van where the back van door is, so it's possible that rain could blow in on a stormy day onto this housing. And so, for example, Thomas's van, everything was enclosed in his power box, and the breaker for his solar panels, so these things, this was not exposed, so we didn't put that in a box because it was hidden, deep within his power system. This one behind me, I don't have any have any room, so it has to be located over here. There was no room here or down here to install it. So one thing you need to think about when you are putting together your power system is, can you do maintenance on it? So if I was building a power system in my van, could I take my panel off and then actually, take a battery out if it went bad for some reason, and then pop it back in? So here we can take the panel off. We can slide these back after we unstrap them. We can slide these batteries out, put them back in. Very easy to get to. If a fuse blows over here, it's very easy to get to. These two units, very easy to unbolt these and take them out. This inverter is a different story. This inverter it's living here. This is where it's going. If I did make it to where there's 3 connection points, so you could unbolt the 3 connection points, but you would have to get somebody to help you and pull this cartridge out. This weighs 65 pounds, so just heads up. But back here is really only the room we have. We have our solar disconnect, and then we also have our battery disconnect. So this is an example of what is back here. So we have this type of unit. So this is the Blue Sea System disconnect. So these 2 cables, just this positive cable. This positive cable comes down. We have one coming from the battery, and we have one going into the Link's distributor. Both of those are coming up through here, and they go to our disconnect in the back. So not only do we have our solar that we can just pop back here, flip the breaker, shut off our solar, but we can go over here and we can turn off our whole entire power system. We can disconnect it. So over here, this box is it's very nice because inside it has a little section to where you can just snap in. You can snap in the breakers really easy. So if you had to ever replace them, very easy to replace it. And then last but not least, before we actually start cutting and crimping some cables, we have our ventilation. So on this left-hand side over here, I know you guys can't see it. We'll show it. I've tried to put it maybe in the thumbnail, but we have these ventilation plates. So these are from Penn Elcom. We put a link to them in a previous video, but let's see here, Penn Elcom. Vent. So if you type in Penn, Penn, Elcom vent, and you can go over here, and these vents are called recessed dish perforated, so they look like this. And what's cool is, as much as we can, we want to do passive ventilation, so stuff that kind of creates convection. So for example, one of these vents is down here on the side, and so there's an intake fan on the bottom of the inverter, and so we want to take in fresh air from the bottom. It's going to come up through the inverter, and up top here we'll have another plate directly above the exhaust hole for the inverter, and the hot air is going to exhaust through here. The fan's pretty powerful in this inverter, so not only are we going to get the inverter being cooled as well, but we're going to get that convection to pull from the kitchen galley. Behind it, there's going to be a slit. It's about 2 inches. And so we'll have air coming from there, pulled across here, so pulled across these heat sinks with the inverter as well, and then up through the top. So we'll probably have one plate here. After monitoring this, if we need to do one more plate, we'd put it right here above the distributor. It's not the distributor that gets hot, it is the two chargers down here. There's a massive heat sink on the back of these. So the heat sink is as wide as these units, and it's about 1.5 inches thick. So what I've done is I've allocated a bunch of space on the back of here so that there's a lot of room for this to get out and escape. All right, so that's all the components. So the next thing we're going to do is we're going to get right into the cables. So if you guys are still watching this, we are moving on to cutting these cables. And we're going to talk first about the tools that are on this list. So here's our list. So on the right-hand side, we've got a bunch of things. So we got our hydraulic crimper, we got our cable cutter, our crimper for our ferrules, some tools for wire stripping, the cable stripper, which that is really awesome, and then another set of crimpers. So essentially a lot of tools. So let's go ahead and talk about what we need to use to crimp all this stuff together. First, let's talk about what we got to cut the cable with. Now, when you have cable this thick, it's almost, I don't even say extremely difficult, but if you have cutters like this, or you have some like aluminum tubing cutters, such as these, like metal cutters, do not use these. You need to buy a tool specific to cutting cable. So it has this type of shape so that when it cuts it, you'll get this very clean cut. Now the reason that clean cut is important is because when you strip this wire, when wires are this thick, they are very precisely made to go into this. So if you cut this and you fray it, it's almost impossible to get it into this lug before you can crimp it. So you need to have something that's going to give you this nice, clean cut. So what we're going to do, and this may take a while, so hopefully you guys are up for a bunch of questions, conversation this evening. By the way, if you've just joined us, you haven't subscribed, definitely subscribe to the channel. We have a ton of videos on how to do DIY everything to your van. Installing windows, installing max fan vents, just a lot of DIY tutorial videos. A lot of the live streams cover topics just like this. So we do a deep dive into all these topics, all this technical stuff. The live streams are very long, but they're really meant so that, you can participate when we're live like we are today, and then you can go back and then pick out a section that you want to get some specifics on. Because it does go pretty long, usually about an hour and a half. I'm saying that now because we're going to start connecting these batteries together. And we're going to do it live, so it might take a minute. But I'm going to explain to you my process for doing this. So essentially how I put the lugs on, crimped it, and then heat shrink these. I'm going to do the same thing, except now I'm going to do it for the batteries. To me, this is pretty self-explanatory. I have to get power from here to here, and I want to do it equally. So I want my positive and negative lines to be the same length. That's pretty simple. When it gets to the batteries, this one gets a little more complex, and that has to do because you're using such a thicker gauge wire, and it's just it's a little more time consuming. So today I'm just going to show you my process. And if you have any questions during this live stream, put those in the chat below, and I'd be happy to get to them. We'll pause, we'll answer them. So let me get this board out of the way before it falls. So we're going to connect these batteries. If we have time, I may drill and connect the solar connections over here to these, but that just depends on kind of whatever questions and stuff we have. Also, if it gets too late, so because we're on East Coast time. All right. So we talked about this. So this is what we're actually going to cut the cable with. And again, this is on the DIY Van Build cheat sheet. So make sure you guys check that out. Head on over to vanbuilderhq.com, or you can click on the link that I'm pasting here in the chat, and that'll take you right on over to the landing page where you can put your name, email address, and then that is going to take you straight to, it's going to send it right to your inbox. It's completely free. So this list of 250 curated items from Amazon that I use in the shop every day, as well as tools, which we're talking about right now. It's on the DIY Van Build cheat sheet. You can get it by going to vanbuilderhq.com, as well as clicking on this form. It'll come right to you. It's completely free. So this is one of the tools, and this tool is one that's over here. So it is this, the cable cutter. But it's under tools. So just check it out from the DIY Van Build cheat sheet right there. This is number one, you're going to cut your cable. Number two, you're going to want to make sure that you want to have the cable to cut. So this is on the list as well. This is 4/0. So that's 4/0, and it's completely okay if you guys have no idea what this means. This is what this channel is for. So 4/0, you wonder why it's just not called 4/0. That is just the name of the wire. So there's a bunch of standard wire sizing. We have 4 gauge, 6 gauge, 8 gauge, and then we have it go backwards to 1/0, 2/0, 3/0, 4/0. It's kind of confusing, but when you get to the 4/0, it gets very chunky. It's very, very, very heavy. It's also very expensive. So if you're ever considered putting a second alternator in your van, it might be more conducive to go ahead and say, look, do I have any more room for some more solar? Do I have any more capacity with my current alternator in my van? Or could I increase my battery bank size? Because when you go and commit to a second alternator, it's great. You'll be able to charge your battery bank system up in maybe like 2 hours. However, the cost of that alternator, the second alternator, is very expensive, sometimes up to $3,000. And then the wire that you're going to have to run is expensive as well. So I think this is, how much is this? This is 10. Let's head on over to Amazon real quick. So if we get the 4-aught, and I like to use Windy Nation, but the 4-aught 10 feet of black and red is $150. So if you needed to go double that, so in this build we've almost used double. We'll probably use about 15 feet. The extra 5 feet is over here for this unit. If you were very conservative, you might be able to get away with 10 feet in here. But I'm going to show you why I'm having to use more of this cable. So I have to use more of this cable for the next reason that I'm going to explain to you. When you have batteries side by side, that's the perfect scenario that you can be in. Each lug that's going to come here and connect the batteries is going to be the same. What happens when you have 5 batteries this orientation and then you have one hiding behind here? Each battery needs to be equidistant in cable length from battery to battery so that the power distributed is nice and even. When you put a battery crooked like this, and it's not in the same orientation as these, you've changed the whole thing. Now this first battery becomes the battery that the rest of them need to reference off of as far as lengths go. So what we're going to have to do is from this point here to this point here, so that's our positive to positive. Back here, our positive to positive is very short. So for example, in a perfect world, we'd only have to cut, let's just call it a 6-inch piece of cable. But now we're going to have to cut let's see here, it looks like we're going to have to cut an 11-inch piece of cable. So that additional length is going to have to be wasted on battery 2, 3, 4, 5, and 6. And that's just the way it is. So you're going to have to do that for it to be a proper install. You're not really wasting it because by doing this orientation, we're able to put our leaks distributor in here, and we're going to be able to keep our battery system very tight and compact. I mean, if you really look at this, I mean, this is the most compact power system layout that you can do in a Ford Transit. If your height is limited, as well as your width. I limited the width on this system because I wanted to have the ability for a customer to put 2 slide-out trays from Flatline Vanco. We're doing one in the spec build, but if the customer wanted to add another one, I want to have enough room to where they have space to do that. So that's kind of the theory behind here. So that tray comes right up against this, and I have a 1-inch offset for the tray. So that's why we are nice and compact. All right. So we have our cable, 4-aught, we have our cutter. Next, we need to have our lugs. So that's what these are. And look, they're humongous. So the ones that we used for the alternator charging from the engine is this size. So that's 4 and 6 gauge on these is very similar. For example, you guys can see there's not that big of a difference. One's 4 gauge, one's 6 gauge, but these two terminals are what connect the engine to our charge controller, and then they're also what is going to connect our solar to our charge controller as well. So when you step up to this lug, it's quite the difference, as you guys can see. This is the big boy right here. This is what's going to take all your current from your batteries, take it to your inverter, as well as supplying your AC unit. So a lot of current coming through here. What's important about this, if you can do it, so we are talking about this sheet right here. If possible, try to find UL listed lugs. Now the ones that are on the Van Build cheat sheet, those are UL listed, so you can see that in the description. But if you're shopping on Amazon, just be careful. It's not the end of the world. So some of these tiny ones, that's not stamped on the terminal that it's UL listed. But if you look on the box, so you can buy these kits. This is all on the cheat sheet as well. So these kits says UL listed, but it's not stamped on here, so it's a good place to start. You just want to be able to, when you get it, you want to have high quality looking, nice and thick terminal. You don't want something very flimsy, and if you can get it copper, perfect. They also have some tin copper, but the ones on the list, try the ones on the cheat sheet first. So try to get these UL listed if you can. This brand right here, this brand actually has the UL listed stamped on the lug. So this is the brand. So I got a bag of these, and I've got a bag of these. So why do I have two bag sizes? So it's the same size lug, so it's still 4/0, but the ring inside here is two different sizes. We have a 3/8 inch ring, and then we have a 5/16. So we got 3/8 and 5/16. So that is going to be dependent on your battery post. So what bolt they have in there for connection, and then it's also going to be dependent on how you're connecting it to your bus bar or links distributor in our case. How it's going to be connected to these. So when you buy these components, traditionally you're going to have your power input is going to be a little bit more chunky. It's usually going to be the 5/16. And then when you go to the, let's make sure I'm not saying the wrong thing. So when you connect this to, like for example, there's a shunt behind here. So the shunt's what's giving you the reading of your power consumption. The shunt is 500 amps. So it's typically going to be a 3/8, really big hole on something like that with that much current capability. Your battery disconnect is probably going to be the same thing. It's going to be 500 amps rated or more, and it's going to probably have the 3/8. When you get to the links distributor and the mega fuses, you're going to look at more, something along the lines of a 5/16 inch. So this is the smaller one, so you guys can kind of see the difference. All right, here we go. So this is the bigger one, this is the smaller one. So the same cable size, but where you bolt it is different. Now it's important not to cheat. So you don't want to buy a whole kit of 3/8, and then when you go to bolt everything together, you use a 5/16 screw, because the surface area, that is the mounting, the surface area is what is transmitting the electrical current. So the more surface area you can get, the better the connection and the less resistance. So if you don't use something that's the right size and it kind of wobbles like this, it's just not a proper install, and it could be a potential problem in the future. So you're going to need 2 of these for a typical power system. So we've gone ahead and measured the top of our batteries, and we know that the top of the Renogy is 5/16. So these, all these posts up here are going to be the 5/16. Now, one nice thing about Renogy is they have a shelf mode that they put the batteries in. And if we go ahead and measure this real quick, it should be off. So, yep, so it's showing 5.4 volts. So they're in storage mode, and you can go through and check all of them. 5.3, 3.5, 5.3, 3.5, and then this one over here, we got 3.5. So we don't have, 13 plus volts coming out of these. Now we don't want to short anything, but technically the batteries are turned off. All right, so we got our bag of 5/16, and just make sure before you start that you have enough of these. But essentially, that's going to go there. So once we have that, we'll go ahead and we'll measure our first connection. And then when we go to actually crimp our lug, we're going to need the next component that's in our tool list, and that's going to be our hydraulic crimper. You can get a manual crimper, but the hydraulic crimper I like because it makes a really nice connection. And so with this hydraulic crimper, you're going to take your lug, push it through here, and then you're going to shut this wheel or this valve, and then when you pump it, there's a piston that comes out, and when you get to a certain point, it's going to grab the lug. We're just going to barely do this because I need to use this. But it grabs the lug, and then this is where you can go ahead and strip and put your wire in. So for right now, we're going to release the pressure, take our lug out. We don't want to crimp this yet. But we come to our next tool. So this is on the Vanbuild cheat sheet as well, but that's the number. And it's going to come with these dies. They're interchangeable. So right here, you see these dies? Now, they're going to come in a metric number, but when you buy them, you can convert the metric number into your aught size. So for example, this 95 is equivalent to a 4/0 crimp. And I've just put a permanent marker and drew all those numbers. All right, so moving along, we need to strip our wire. And now we come to one of my favorite tools, which is this guy right here. This thing is really cool. So there's a razor blade, and the wheel, you can change the height of this razor blade. And not only is the razor blade there, but it is in a specific orientation so that when we have our cable come through here, it's going to cut the sheath of the cable, but leave the copper intact. So it's not going to cut. It's going to cut through the rubber part, but it won't cut through the copper wire if you adjust it properly. So when you first get this, you're going to want to put it down like its most minimum setting. Get a piece of wire that you're comfortable messing up. Mine is already dialed in to where I want it to be. So what I'm going to do is, and we'll just do this for an example purpose first, and then we'll get into actually crimping some stuff. Once again, feel free to ask questions. This is a learning live stream, so it can be anything van related. It doesn't have to be on the power system that we're doing right now. So when I do this, I take my wire and I find out where in the system my wire is going to connect. The first thing I do is I find my length, so where I need to cut the wire. And what I'll do is I'll take my permanent marker and I'll mark it. And that is where I go and use this to cut it. And we're going to do this live. We're going to go through and connect these, so don't worry. It's on the way. So I cut this first. So once I cut it and I find my length, so for example, if I was going from here to here, I take my wire and I go from here to here. And so that's my first step. The second step is these power cables are extremely, what's the word? You can't really convince them because they're so thick that if you put it in this way, it's gonna come right back. They're hard to twist. So like if I twist this end, I can't think of the word. My point is, if you have a battery lug like this, but you need to twist the wire, you're not going to be able to do that. It's not going to twist. So the way the orientation that you crimp the lug on needs to be correct before you actually just crimp the lug on. So this will make sense when I do this. So say you have the wire here, and you need the lug to be flat and flat over here. So when you get ready to crimp, what you've done is you've said, hey, this is the way that this needs to look, just like that. Not like this, but in line, because it's going up against a flat surface. If you crimp it wrong, it's really hard to twist this and get it correct. So what I do is I take my wire and I put it on here. And then your next friend is your zip ties. Take your zip ties and zip tie the wire in place. Then what you want to do is take your marker and you want to mark the orientation that you want the lug. So for example, I just use like the number 1. So it's just like a straight line. And so when I pull this back, I know that this 1 or this line means I need to put my lug flat. So not like that, I need to put it flat. So if you guys can imagine, just imagine that there's an imaginary, well, you actually can do this if you want to. So imagine there's a line and you want to keep these lines aligned. You don't want them to be off. So you want them to be aligned. That way, when you do your next step, which is to measure how much of the cable you want to cut off. So what I do to find out how much I want to cut off, I go and I put a little dot right there. So that dot is my reference to where I'm going to cut the cable off. Because think about it, if you strip off this line, then you don't know your orientation. So for right here, where that dot is, we're going to take our cutters and we're going to take the blade and we're just going to let go because it's spring activated, and we're going to put it right here. We're going to take our thumbnail, and the thumbnail is going to be your guide to this. And we want to go opposite. So we're going to go down and come back to ourselves. So we're going to come down. And we do not want to twist this. We want to keep this very accurate. So let me get this thing straight again. There we go. So this thing will turn on you, but you want to click it right there. So see how it's clicked? So this is the direction of the blade. So once you have it open, find your black dot. Okay. And you see that pin is going to pierce the cable, but only deep enough to where you've set it. And then you're going to use your thumbnail as like the guide, and you'll see why. This will walk on itself, so you want it to make a perfect circle. You're going to want to go nice and easy following your thumbnail. Then come straight down, and then you'll feel it break the wire. So once you're done, you just push up and take this out. And then if you can see, you see how we've cut the wire? So we've scored the wire on all sides. Do you see that? So that way when we take it with our hands, we want to twist and pull off. Because we don't want to fray the wire. If we fray the wire, it's really bad. You're not going to fit it inside the lug. So we take our wire, what we've just scored, and we're going to twist and pull off. Now, if I can show you guys, if we could look on here, do you see how I have a one wire here? So we got about 1, 2, 3. All right, so I've twisted this, and so we lost about 3 strands, which tells me that I actually probably need to go and back off of this just a little bit. But 3 strands is okay. If you cut a lot of strands off, you need to redo your cable. Because remember, the more strands you take out of this, you're increasing the resistance, and it's not a 4/0 cable anymore if you keep removing the wire from here. Hence why there's more wires. More wires is less resistance, more current can flow. So just make sure that you haven't really cut into the wires. And you can just take it and then just do this. Just twist it and pull. And as long as nothing comes out, I can count 1, 2, 3. So we had 3 little of these that came off. So it's pretty, I call that perfect. So look at this. This is why it's so important that you don't fray the wires. Because when this goes into here, as you guys can see, that is how tight of a fitting you're going to have. Look at that. Do you see? It's that tight. So if you had frayed this, it's going to be next to impossible to put it in here. Now, this is probably the limit. Do you see where I cut it? To me, a perfect cut is probably that much. So I could have gone that much more. So where this starts to taper, if you can kind of smush this end in there, it just makes for a better connection. If this is what you did, that's okay. But that's your bare minimum. You do not want it to be like that. You need it to be at least that much in. Because remember, you're going to crimp down on here. And if you don't have enough wire and you smush it out, your connection is not going to be as strong. So we're going to go ahead and put this back in here. And then remember, we want to make sure that wherever that line that we had, we want to make sure that before we crimp it, we orientate our cable so that these 2 lines match. So once these 2 lines match, we can go ahead and hold that inner crimper, put it in here, and we can crimp the lug onto our wire. So that's how you crimp these guys. All right, let's go ahead and we actually might be able to use this. So I don't want to drop it and damage it too hard. This stuff's expensive. It adds up. It's like 80-20. Your offcuts, you want to keep them. You don't want to throw them away. So now what we're going to do is we're going to measure between our 2 batteries up top here. I'm trying to think the best way to do this so you guys can see, because you can't see the batteries. So let me move this out of the way, and I'm going to take the batteries out. I'm just going to move them down so that we can see them. And is very hot tonight. Let's see here. There we go. So hopefully that wind is not going to come on the microphone. If you guys can hear the air from the air conditioner on my microphone, somebody tell me in the comments. All right, so let's move over here. Clean off our workbench. The fun part about this is the heat shrink. That's the best part. That's the most fun about doing kind of van electrical systems. It's making everything look, really nice and professional. So we probably won't get to these wires. It just, yeah, we won't. I think time-wise, unless you guys have more questions, the more questions you guys give me, the more we'll stay involved in the live stream, the longer it'll go. But we're going to just do 2 batteries, and that'll pretty much be what we get to tonight. So we're going to go down here, and we're just going to take these 2 batteries, and we're going to put them in the same orientation as these 2 batteries. And that way you guys can actually see what I'm doing, as opposed to it just kind of being hidden up here. So we have 1 battery in this orientation. And our next battery over here, we have it in this orientation. So right there we got 1, and then we've got this other one. And again, this is not an ideal situation, but what we've done is this gap has allowed us to install this and maximize our space. If we didn't have the air conditioning unit and this disconnect having to be located back here, I was going to slide this over and add another distributor with 2 batteries, but that's a whole different story. All right, so this is our setup that we have. That's about as close as I can get. Hopefully you guys can see this. So over here, let's put another battery. So again, in a perfect world, we would be going positive to positive, negative to negative. So our run of cable would be this much. So we would take this cable and we would probably, so here's a little hack for you. So before you get started, go ahead and just get your terminal, your lugs out, and just take the bag and go ahead and grab the lugs that you're going to be using and put them on the top of the terminals. I'm going to show you why here in just a second. Well, I can just tell you why. This is how we measure how long our cables are going to be. All right, got those 2. Let me go grab another bag. Let's see, so we need 1, 2, 4 more. All right, so I'm just going to break all these free. Now, even though these are in shelf mode, they still have power coming out of them, and you don't want to short the battery. So just be cognizant that always treat your electrical system as if it's live, even if it's completely shut off. Just so for example, these 2 terminals, we get a positive and a negative here. We don't have it connected, so it's not possible for it to do anything. Just if this were in a system and you were working out at home, you were kind of watching this video with me, you may think that what I'm doing is what you're okay doing. It's not always true. I don't know what setup you have at home. All right, so we got all our terminals here, and you want the terminals in place because what we're going to do is we're going to use the end of these lugs to actually measure the length of our cable. We want to take two things into account. We want to take into account how much wire is actually going to be stripped away, as well as how much after we strip it is it going to be able to fit into the lug. But the benefit of having this weird orientation, the downside is we're going to be using more cable, but the benefit is that we have a little bit more forgiveness over here because our cable ends will be the same, but whereas in a world where we just cut a cable this short to connect these two, since we're going to have a longer run, which I'll explain in a second, we have a little bit more wiggle room. So what do I mean by that? So perfect scenario, you have batteries like this. You're having a negative terminal connected to a negative, and then a positive connected to a positive. Your cable run is going to be very short. So for example, this run right here would be, we would cut a cable 5 inches long, pop it in there. Okay, that's because we don't have this one. As soon as we change an orientation, this becomes our default standard length for all the batteries. Because we don't want charging power or current draw to be coming in different links. So we don't want it to be able to, we don't want the electricity to flow or favor one side than the other side. So now that we have a odd setup with this different orientation battery, we're going to go ahead and start from the positive one, this terminal right here. And we need to go positive to positive. All right, so these two are the one, this is our length now. So what we're going to do is let's move this out of the way so that we don't touch this. And then we're going to take our lug over here, and we're going to take our lug over here. And this is going to be our distance that we need to go. So once we have these lined up, so that's our first, this will be our first run. We need to take our negative, and it's going to go to this one. Notice it has the shorter run. But what we need to do is we need to match this with this. It's not that complicated, but you can kind of see this changes where this is going to go. So we're going to start with our longer one first. Then we'll cut a piece of red, and we'll cut a piece of black. We'll do the red one first. Once we put this in, and we're going to crimp it. And then once we have it crimped and finished, actually before we crimp it, you do want to measure and then go ahead and cut this. But we want to crimp it because what we're going to do is we'll take this off and we'll just test it to see, is there anything weird? Are we going to have to actually turn the terminals or something like that? That's just a possibility. So let's go ahead and keep going. We're going to connect this positive and this positive. So we'll just do this red first. So right here, we have our length. Just got a straight shot. Also keeping in mind, are you going to have any type of battery tie down? So let me get a tie down here really quick. I'll show you what I mean. So we have some 80-20 corners that are felt padded and that are going to compress the batteries. So from front to back. When you're putting a power system together, always think that your car has the possibility of getting into an accident. if you get a fender bender or you're getting on, T-bone or head-on collision, think about each of these batteries, which weigh. Let's check this out. We've got Renogy. So if we go here in Renogy, let's scroll on down. Let's go to specifications. So each one of these batteries is 26 pounds, okay? So we've got 6 batteries at 26 pounds. Let's just do some quick math. So we have 156 pounds of just the batteries, not including this. So, if you get into an accident and this is part of the van, that inertia that is within these batteries, and you need something to contain it. So that's why I use 80-20, because this is solidly in here. I make it to where if that happened, the batteries are still fine, even if this fails. So this strap is going to go here, okay? Because we want to make sure that we capture all the batteries. So what does that do to our cable lugs, our battery lugs? So that's something you need to think about. So you need to know that you need to be able to strap this down to where this strap can go underneath this cable lug run. But you need to also understand that to unstrap it with the lug in place, you need to make sure that that's possible too. So however you're strapping down your batteries, make sure your lug works plus your strap. Because everything in the van's connected. All right. So let's keep on moving on. Okay, so we've got, so from this side, we want to have 10 inches. So 10 inches of cable length. So let's go ahead and measure this. Let's see if we can actually use this piece. Pretty sure we can. Oh yeah. So this is 15 inches, so let's go ahead and take our permanent marker. We're going to mark off 10. I'll just triple check really quick. Yeah, so 10 inches should be perfect. The good thing is we've already stripped off our end over here, so we're just going to come over here, mark 10, and we're going to go cut it. If I had 3 hands, it'd be perfect to show you guys this, but let's go ahead and cut this. So we got our cable, and right there is where I've marked it. So when you buy this one that I bought, it doesn't really fit through here. It can, but you may nick the wire, so you want to actually push this through the middle. Then find out where your cut is. And so let's see if I can do this and show you guys at the same time. So get it right where you want to cut it, and make sure it's perpendicular. Okay, there you go. So see? And then all you got to do is just come straight through. All right, now watch how clean of a cut this makes. Do you see that? It's perfect. It's almost shiny how clean of a cut that specific tool makes. And that's really important. That's why you need to have the specific tool. It's on Amazon. It's very affordable. So next what we're going to do is, and don't do what I did, see how I actually hit the wires. So I want to go ahead and roll those back in so I can still crimp it. What I typically do is I'll cut one end like this, I'll strip one. I'll go ahead and crimp it so I don't screw up the other end while I'm messing with it. So let's go ahead. Let's unscrew this battery terminal. And let's go ahead and make our first crimp. All right, so the nice thing about this first one is we don't really have to worry about, well, actually you do. So make sure that, so see how this has a natural bend like that? We want that natural bend to be like this. We don't want it to be crooked. So we want that bend to be like this so that when we put them on both battery terminals, it stretches out like that. And this is kind of like an OCD thing, but you know, if you take time and do the job right, you'll be really proud of what you put together. So what I do is I just get this tight enough to hold the lug. And then what I do is to keep it in the same orientation, I take my finger and I hold the lug here and I hold the wire with the bottom of my finger. And essentially what I'm doing is I'm just kind of squeezing the two together because I want the wire to be pushed in all the way. I don't want it to come out, you know, at any distance because I want to make sure that the most wire can be put inside the lug as possible. Now you'll get to a point where you feel like you can't go anymore, and that's when you want to check to make sure that you have you don't have the die over compressed. And then I just leave it in here for about 3 seconds, and then I back off this wheel. So you can see I have it, it's crimped in there. All right. And so what I'm going to do is I'm just going to turn this wheel and it's going to expand and the piston goes away and then this falls out and you just pull the lug out. So once you're done with that, you can see how good of a job you did. And so right here we have a hydraulic crimp. It is very professionally done. And go ahead and, on your first one, do your best to really try to actually pull it out. Now don't worry when you see this. So you see what I'm doing here? It looks like it's pulling out, but it's not. It's this outer housing, because watch. I can just push it back up, and it's flush. So don't think you did a bad job. So you want it flush because the next part, I'm skipping ahead because it's getting late. We're going to go about 15 more minutes here. But if you guys do have any questions, get those going in because we got about 15 minutes left of the live stream. So I'm going to try to hurry this up so we can get at least one cable crimped and you guys have something to work off of for your own DIY. All right, so we have our heat shrink. Now you can get black and red heat shrink if you really want to kind of keep the continuity here. I did it for these because that's what I had left from a previous project. We're just using all black for the top. We are keeping the positive cables red and the black negative, but the heat shrink is going to be all black heat shrink. All right, what we want to do for the heat shrink is we want to put the heat shrink about halfway down this curve, and we're going to end up about 1/4 of an inch from the lug. So we're going to take our heat shrink, make sure you got a nice clean end, and then now you're going to go and just measure your heat shrink, and you're going to cut it, and you shouldn't have that much. So for example, I have just a little over 1.5 inches. Now, why is that important? So you want this part, the middle of your heat shrink over the middle of that lug, just like that. So that's kind of what you want before you turn the heat gun on. The reason is, this is your mounting surface. You do not want the heat shrink to be here or here, because you're going to be crimping on top of this plastic, which is an insulator, and you're not going to get a good connection, or you're not going to get as good a connection that you could have. So you want to pull this heat shrink down to about right there. So I always cut it to where, so let me just smush this with my hand really quick. So you see where that raised piece is? That's about perfect, just like that. You're still protecting both sides from corrosion. It's for looks, but it's really for corrosion. It's so that you're not getting moisture or anything like inside the cable. So that's what it looks like. We're going to go over here, and so I upgraded. I used to use a DeWalt battery powered. Battery powered is terrible for heat shrink. Don't do it. Go to Harbor Freight and get one of these corded ones. This thing was like $20 at Harbor Freight, or like $24. Let's see here. Okay, that's not that loud. Hopefully this is not too loud. I'm gonna go ahead. Let's see if I can do a tutorial and heat shrink at the same time. So we have 2 flaps. So you see we got one on the left and one on the right. You want to heat the flap sides first before you hit the middle. So these edges, you want these edges to suck in first, and then you want to do these middle sections. What you don't want to do is kind of come left to right, because it's going to sandwich and it could make a crease where you don't want a crease. So what we're going to do is just going to, we're going to heat one side. That's why you can't do this live stream. Doing 2 things at one time. My first live heat shrink is my worst one. Okay. Not too loud. All right, perfect. So I'm going to do, I think it's loud when I do this and talk. So we're going to do one side, flip it, do the other side, and then we'll do the spine, I guess I call it, in the back. So here we go. If you guys saw behind the scenes, this computer desk is like right on top of this power system. All right, here we go. So we're going to do the left side, and we're going to flip it, and we're going to do the right side, and then we'll do the top and bottom. That's the way you want to do it. So we did both sides, now we're going to do the top and bottom. And then I just give it like a final 360 spin with the heat. Now, in a perfect world, you would be able to find the heat shrink that has the adhesive on the inside. It's not necessary. I've bought 3 off of Amazon, and for some reason they don't have the gel like in the inside. But if you have the gel, you're going to want to make sure you get it hot enough to where it actually melts to make that seal. But as you can see, we have a really nice professional heat shrink right here. And then this top tip, you want to make sure you really heat that top so it folds down over the lug. So you see that? Really gets over there. Now, what is the key to making this look so professional? So I'm going to teach you right now. That way, anytime you do this, it'll be the most, everybody, all your friends will say, where did you buy those lugs? And you can say, I made them. Okay. This is what makes it possible. If you guys don't have calipers, get a pair of calipers. These are from Harbor Freight. These are the fancy ones from Harbor Freight. But we're going to take our calipers and we're going to measure the maximum width of our lug. Okay, we're going to do millimeters because that's how I buy this stuff. So we're going to take our calipers, we're going to open it up, and we're going to go here. It says that we are 25.5 millimeters. Let's see here, maybe 25.6. It doesn't really matter, you don't have to be that precise. So 25.6, okay? 25.6, so let's remember that. So let's go on Amazon and let's type in heat shrink. I know I haven't changed the window yet, just give me a second. Heat shrink. I'm looking at my past orders, so don't want anything jumping out that you guys shouldn't see on here. Okay, so here it is. This is our 1-inch heat shrink. So this is what I bought. But I had to go, where did I have to go? So heat shrink, 1.5 inch. This is the sneaky thing about Amazon. Since everything is kind of like, no holds bar, anybody can kind of sell stuff on here. That's the reason I did the, this is, again, shameless plug for the DIY van build cheat sheet. That's why I did this cheat sheet, is because I needed to keep up with the stuff that I knew was accurate. Because if you go on Amazon, stuff changes all the time. And if I'm not getting the exact, these descriptions are crazy. But if I'm not getting the exact thing, I end up doing what I did the other day. And this is why that cheat sheet is going to save you money. I bought these two. I got like 2 16-foot pieces of stuff, of heat shrink I can't use because I bought 1.5 inches. But when you buy 1.5 inches, it's 3 inches. Anyway, I'm going to show you what to look for. There's this chart, okay? And this chart shows different values than a normal person would say, oh, I need 1.5 inches piece of heat shrink. Well, that's not always true. So remember, we just looked up and we have 25.6 millimeters. So we're going to go to this chart. We're going to go to inner diameter before heat shrink. Very important. Before heat shrink. And then we're going to go scroll down. And we had 25.6. So see right here, we've got 25. Right here, 25.4. You see that? 25.4. So this is where it's weird. I normally would get like 1.5 inches, but this says that I need 1 inch. Now, 25.4 millimeters is 1 inch. That's accurate. But the last time I bought this, it was a different value on Amazon. That's all I'm saying. What I'm saying is always double check the manufacturer you're buying from so that is 1 inch the same as this scenario? It is, okay? 25.4, 1 inch. We need 25.6. So the good news is we're gonna order 1 inch. So after making sure that this was 1 inch, I went through and I ordered 1 inch. So, and I got like 10 feet of 1 inch. But always check these charts. Yeah, hope that helped. So now that we've measured this, we've got our heat shrink. So you remember how I said that was 1 inch? This is what I'm talking about. Okay. So this is 1 inch that I ordered from Amazon, but let's measure it. Okay, you ready? It says it was 1 inch. Look at that. See, it's not. It's 1.5 inches. So the good news is this was $16 for a roll, but yeah, that's why this the Van Build cheat sheet is good, guys. You should download it. So I ordered 1 inch. I got 1 inch. Where'd it go? Yeah, this is the size I got. 1.5 inches. All right, I hope that was really confusing. Let's get back to making cables. So I'll also add that to the list, but here's one in. All right, how much time we got left? We got a couple minutes left. Let's go ahead and finish this cable and go ahead and end the stream tonight. As we're winding down, make sure if you have any questions, guys, let me know. All right, we're going to take our cable. We have our terminal in down here. And then now we're just going to triple check to make sure our length is good. So after we crimped it, we have a little bit longer length over here. So we're not going to panic because this 1/8 of an inch that's a little bit longer, we should be able to cram into the lug and get an accurate, get a good crimp. But we're going to go ahead and make sure that our black cable is 10 inches as well. So now that we have this in here, we're going to go ahead and mark where we need to take our stripper and go ahead and strip the cable. And so this one is a little bit lower, but that's okay. We're going to take the excess and put it deeper into the wire lug. All right, so let's go ahead and we're going to pull this out. We're going to get our position on here. And I'm going to come back just a little bit. All right, get our finger right there, and we're going to go ahead and just spin this around. Here it cut through all the sides. Then we're going to go ahead and just twist. And we didn't adjust it, but it looks like we lost maybe three little wires, so we're doing just fine. So this is a little bit longer, but check this out. We're still going to be able to, well, first, remember we need to make our mark. So we're going to make our mark right here. And so that shows that that's the orientation that our lug needs to go on. So we'll go ahead and undo our lug. And you can see we're going to be able to stuff the wire into that lug. We're going to be okay. And don't worry about marking all this up. You can take some denatured alcohol and wipe it off, but let's make a mark. And then let's go ahead, put our wires in here. We didn't fray them, so this should be really easy. See, goes right in. Now see how it's a little tight? Go ahead and push, and you see how you can close that gap really quickly? So go ahead, push. And so you can stuff it in there, and then now you have a nice clean insertion there. Tristan, good question. I have not looked up what you should crimp, but the goal that you're really trying to achieve is you want to have as much connection from the cable into the lug as possible. I will show you one kind of trick or rule of thumb for hydraulic crimping that I learned, and so we'll do that in just 1 second. In a perfect world, you want to have as much cable into this as possible. You're really only going to get, I'll make a line. That line right there, so this one, it's a little wavy line. That's about as far as you can get the copper in there. The goal is to make sure you have a, from here to here, you have a good compression crimp. Because it's almost, don't quote me on this, but it's almost like a cold weld. Like you're compressing it together hydraulically to kind of make them one. So now that we have this, the cool thing is this one will be over exaggerated than this one, and you're going to see a little bubble right here on the end. And I like to see that little bubble. That shows me that I've flared the inside strands and that they're really solidly in there. And then I'll also show you a thing where if you mess up, you can recover. So we'll do that too. So let's go ahead and put this in here. I think it's really just challenging with the big crimps because it comes down to cost. Like, you don't want to, waste money by making a bad crimp or something like that. All right, so we're going to go in here. I need to make sure that both of my lugs are flush. And then I'm going to put this in here. Okay, looks good. This one I'm really going to make sure I push it in here as much as I can. Okay. So I got it in there. Notice how both of these are nice and flat. So one isn't turned like, 90 degrees or messed up, because this cable is so thick, guys, you are not going to be able to, you can tweak it like maybe this much. That's about as much forgiveness that you have. But then we're going to go ahead and take it, undo it, pull it out. So this may help you guys. Notice, so this is the 4/0 die. If you mess up, messing up means the crimp, the cable went in nice, but for some reason it didn't crimp as good as it should. You can change this out. Now this is Nick's trick, okay? So take this with a grain of salt. You can go to a smaller die, and then you can you can further compress this. So that's what I've done when just an odd situation where the wire may have come out just a little bit, and I really needed to make sure that the connection was good. For a customer van, I get more cable and I'd redo it, but I did that on my van because it wasn't a serious connection. But so to answer your question on rule of thumb, do you see how this has kind of like mushroomed out right here? So I'll show you a lug before and after. I think that'll help. So if you guys can see, you see how the hydraulic crimp pushes it here. Now it doesn't look like it's that much, but remember, it's doing it from all sides. So it's really making an extremely strong connection. But right here, this is all smooth. And then see how this is mushroomed right there? So there you go. You can kind of see the difference. So this mushroom effect that is happening, that lets you know that you've done a good job. And it's extremely strong. It's not going anywhere. All right, so now we're going to put another piece of heat shrink on here, and we'll be done. And essentially that is going to do it. But let's go ahead and cut our last piece. So for your last piece, what you're going to do is you're going to take it, go ahead and cut it the same length. You're going to pop it on over here. Okay, we're going to do one side and then we're going to do the back side. All you got to do is to make sure that it's in the middle. You can pinch it if you want to and kind of give you that little ridge. And just be careful, this thing does blow a little breeze, so it might move your heat shrink like it did to me earlier. All right, as you guys can see, with some time and patience, you're gonna have just a factory, very professional heat shrink. A hydraulic crimp is the best. And so now you have a battery connection, and you're just gonna take this and just go ahead and put it back on your battery. And so that's what we have for our connection. So it has a slight bend in it, and we kind of want that. That's going to give us that ability to, expand and contract if necessary. You don't want it that much, but the main takeaway is that this needs to be the same length as the negative cable as you go through. So even though these are close, I'm going to show you what it's going to look like when we get done. And then that'll be the end of our stream. So thanks guys for staying with me. If you guys are new here, don't forget to subscribe to the channel, like this video, also share it to anybody that you think it might be valuable to. It's doing a DIY build or doing anything with like a 12-volt battery system. You know, they have an off-grid cabin or, you know, DIY van like we talked about on the channel. So that is our positive cable. If we act like this is our black cable, what we're going to do is we're going to show you that, I'm going to show you how aggressive this bend is. So right here, we're going to go ahead and bend it. We're going to put one in the negative side. We're going to put this other one in the negative. And so this is what you're going to look for when you're doing your next cable. And so this may influence how you do the first cable. You know, if it's too much, you know, maybe you can adjust it by a ½ inch or so. But now, you see we have, this is our tight bend for this lug. So we'll have a straight one here, and then we'll have a one bent like this. So guys, hope that helped you tonight. That'll be it for our live stream. If you have any more questions, go ahead and put those in the comment section below. And so what we're going to do is, obviously tonight, this took a long time and we didn't get to doing the rest of the batteries. But next live stream, we'll go ahead, I'll show you, I'll show myself putting together the rest of the terminals for the batteries, for the lugs. We'll show the system put together. We'll pretty much have everything up and running, and hopefully we'll do a full charge on all the batteries, and then probably in about 2 weeks we'll be able to show you a live stream of actually hooking up the Dometic AC unit. So let's see here. We got Tristan. Thanks for the practical tips. You guys you're very welcome. I'm about to epoxy my vinyl down tonight. Yeah. Good luck in doing that epoxy. Remember, the pot life of it is going to be pretty short if you're doing the same method that I did. So make sure that you've got, you know, the vinyl floor, you know, pre-cut out as much as you possibly can. Don't forget to do the trick where you have like a little screw up front and back to align it. And then do that thing where you flap it over, get one side done, flap, move it over, flip the other one up and do the other side. You know, take your time on the prep as much as you can. You know, don't wear pants that are that you want to keep. You know, they're going to get messed up. And just remember, epoxy sticks to everything. But, you know, take your time on the prep and try to, you know, set an alarm clock. Be cognizant of the time, that pot life of that epoxy mix, because it does catch up to you really quick. But yeah. Hope that video helps. Good luck tonight. Yeah, Tristan, hope to see you in a future live stream. You know, let me know how the floor went in. It's exciting. It's exciting to put the floor in. Like when you get there and you get the nice floor in, you get excited. The van really starts coming together. But yeah, we will we'll catch up on this, and then I'm gonna put together a short video. It's probably gonna be about 15 minutes, and it's gonna be on this back panel. So I'm gonna go over just a couple more minutes because I'm gonna showcase to you what's in the next video next week, because there won't be a live stream next week. So in 2 weeks, look forward to seeing this run a Dometic RTX 2000 unit. Look forward to it powering this 3,000 watt inverter. It's going to be really exciting because we're going to do our own in-house test of how long we can run that Dometic RTX 2000 with this power system. But before we go, I just want to show you guys this back panel that I made because it's going to be in next week's video. And next week's video is going to be talking about templating for the power system. So back here in the back of the van, or panel. We've got this panel right here. So this is a 1/2-inch piece of plywood. And back here is what houses our rear controls for the van. So let me try to get this in here. So this is our very nice, clean, and neat controls. We've got our intake down here for the inverter. We have our battery disconnect switch. Now this is all temporary. And then this is our door that we're going to lift up, and we'll have our disconnects for our solar. So this is super precisely cut. Everything is neat. I could just cover this with fabric, and this literally could be my panel. The reason that I'm showing you guys this is not the panel. This is just my precise template, because I have a very expensive piece of wood that is going to be at the back. And so I'm going to show you this. I know the live stream's never going to end, but trust me, it'll end right after this, because we will be done. Okay, if you guys remember, past live stream, I took and I repurposed the Flatline Vanco kitchen galley to put and install the isotherm Cruise 130. So what I'm doing is I had to take out the interior bamboo supports from Flatline Vanco, and guess what? This is the inside. It is a beautiful 1/2-inch piece of carbonized bamboo. If you bought this at a store, it'd at least be, close to $80, $100. So we're going to take this, and this panel will be cut out. And so what we're going to do is we're going to repurpose this panel, and this will be bamboo. So it's going to be just incredible looking. All these screws will be painted black. So the black and the bamboo is just going to look very, very nice. I'm going to add one more detail. So I'm actually going to, curve the edges here. And so this will be extremely precise, the way I like to do it. But we're going to repurpose this panel for this, and then we're also going to do the same thing for the water side. So on the water section, we'll have this plate. You guys might have seen this in the shop, but do you see how we have this from Pin Elcom? Well, guess what else? We have this. This is our washdown. So we'll have like a mirrored effect on the opposite side, which will be the passenger side of the van. And this will be our mixer valve, and then this will be our hose for our washdown. So mixer valve, hose for our washdown, and then we'll have some other stuff up here, which will be like our fill port for the water tank. We may have like a 3-way valve right here, but we'll try to aesthetically mirror controls on each side, and I think it's going to look incredible. So I'm really excited. Everything's coming together. Today we just got the shipment. I've been waiting a very long time for this. Let me back on up. So I've been waiting a very long time on this. We've got 2 components from Flatline Vanco. We've got 2 big boxes that came in. So this will be the mystery to kind of end the live stream with, but we've got 2. We've got this box right here, which is their rear tire carrier. So Flatline Vanco now has a rear tire carrier, kind of like Illuminous and Rover vans, but they have their own design. And I'm pretty much trying to make this, like a Flatline Vanco Adventure Wagon collab. It's not sponsored, but we can talk about that in the future. But this is in the rear rack where we can install a bike rack. We also have that over there as well. So we've got exterior accessories, The kitchen guy is going to be coming back from the powder coater really soon. We'll install the isotherm. We're going to get this power system all buttoned up. And then once this is all finished, we'll take everything out of the van. We'll kind of get on to what Tristan's doing, getting the floor in. So I'm ready to get my floor into this build. So that is what we got coming up in the future. So Nick, real quick, I'll show you this. This is the company, Penelcom. And I'm just going to paste this link into the chat. So Nick, if you're looking for this particular, this right here, this particular vent, it's from like flight cases that they use for, you know, sound equipment, like sound stage equipment. But this Penelcom, so check out the link. That's where I got these. This is from Titan Vans right here, but this, I'm sure they got it from Penelcom. All they did was just bore these holes out. Yeah, this summer is going to be very DIY friendly for you guys as far as content goes. We got a lot of stuff. I got all this going on. And then, yeah, we got the AC unit going in and all that good stuff. So, guys, thanks so much for watching. If you're not subscribed, get subscribed. Like this video. Share it to anybody who you think this is really going to help out. Don't forget about our DIY van build cheat sheet. You can get it super easy. Just put your name, email address. It'll come straight to your inbox. It's really going to help you out. Again, it's that curated list of all my Amazon purchases over the last 3 years, over 250 items. We got more items added to it all the time. We're going to do in 2 weeks, we're going to do a big dump of some new stuff because I've been ordering a lot of stuff that I have not put on the list. So the exciting thing is more stuff is going to come. There's been a lot of different items that have been purchased and some stuff that is just now currently available on Amazon that I use. Don't forget to sign up for that list and get subscribed to the channel. Thanks so much for staying with me late into this night, and hope you got some value out of this video. And until next time, I'll see all you guys in the next live stream.